Welcome to our webinar, Code Quality Assurance in the Age of AI Assistants. My name is Rafael Taubinger, and I am a Product Marketing Manager at IR. Joining me from IR is Marc Thomas, a Security Field Application Engineer who will discuss how AI tools like GitHub Copilot can speed up code writing. He will also highlight the importance of following coding standards such as MISRA-C, CERT C, and CWE, and explain how to ensure your code meets safety and security requirements while using AI tools. Let's get started with this session. Marc, the stage is all yours.
Welcome everyone. Let's start the presentation. Let's take a closer look at the key points we'll be discussing today. Overall, this presentation aims to explore methodologies for effective quality assurance in the AI-assisted development, strategies for ensuring compliance, security, and code quality in embedded systems, the future of developers' roles in the age of AI-driven development. Our agenda for today is then composed in 4 chapters. First chapter, Introduction. The role of AI in code generation. Today we embark on an exciting journey through the realm of AI and its transformative role in code generation. Imagine a world where AI not only assists, but also innovates alongside us. Second chapter, Ensuring Compliance and Security. As we harness AI's potential, we must also navigate the crucial aspects of compliance and security. Let's delve into how we can maintain robust standards while embracing AI's capabilities. The third chapter, the imperative of manual oversight. Despite AI's advancements, the human touch remains irreplaceable. I'll highlight why manual oversight is not just necessary, but imperative for the integrity of our work. We will finish with the fourth chapter, Conclusion. In summary, AI is a powerful ally in code generation. Together with vigilant compliance and oversight, we can unlock new horizons. Thank you for joining me in this exploration. Let's start with the introduction, the role of AI in code generation. AI in code generation, a double-edged sword. Historical background. AI-powered code generation totally transforming the software development. Machine learning algorithms analyze vast amounts of code from public and private repositories to interpret and generate code snippets, functions, or entire modules based on developer input. This technology has evolved from basic code completion tools to sophisticated AI assistants capable of generating complex code structures. AI revolutionized development. Tools like GitHub Copilot represent the forefront of this innovation, offering developers the ability to generate code quickly based on contextual understanding gleaned from vast code repositories. Developers shifting focus when using the AI, from writing to ensuring code quality using different code analysis tools. Collaboration with the AI. Developers need to collaborate with the AI tools and will be not replaced by the AI tools. Acquiring new skills. Understanding AI's impact on quality assurance is almost mandatory. And the real challenge is to ensure code quality. Provide to end users a secure and compliant AI-generated code. As you can see, we have different quality standards here. For aerospace, for general industrial, for the railway, automotive, medical devices, nuclear power, and so on. Each of these industries have its own standards for the code quality. Let's continue. AI assistance in routine coding. AI accelerates the development process through the automation of reusable code components, such as functions. Enhancement of development. AI-powered tools significantly increase the speed and efficiency of development workflows. AI tools provide faster development, improved consistency, focus on complex logic. AI provides developers with intelligent suggestions, reducing the time spent on routine coding tasks and potentially lowering the barrier to entry for novice programmers. Let's delve in typical usage of AI in routine coding with some examples. First of all, data structures creation and manipulation. AI helps with initializing and populating common data structures like arrays and linked lists. Logging functions. AI suggests appropriate formatting and data type for logging messages, for example, printf statements. String manipulation. AI assists with common tasks like converting to uppercase, trimming white space, or replacing characters. Mathematical functions. AI generates code for basic calculation like factorial, logarithm, or trigonometric functions. Next usage of AI is to have a personalized development assistance. Some tools and solutions learn from developers' coding styles and preferences, offering personalized suggestions for code completion, snippets, and code reviews, tailoring the development experience to individual needs. First of all, we have enhanced code completion. For example, tools like GitHub Copilot act as intelligent code completion assistants, suggesting relevant code snippets and functions based on the context, reducing manual typing and boilerplate code generation. Then we have code refactoring and optimization. For example, AI-powered refactoring tools analyze code structures and suggest improvements for readability, maintainability, and performance, enabling developers to write cleaner and more efficient code. And lastly, we have bug detection and prediction. For example, some tools leverage AI algorithms to analyze code for potential bugs and vulnerabilities, allowing developers to identify and address issues early in the development cycle, saving time and resources. Another use of AI is automated testing. For example, AI-powered testing frameworks could automate repetitive test case creation and execution, freeing developers to focus on core development tasks and improving overall testing efficiency. Let's explore now some examples of usage of AI assistance in routine coding. We have a scenario for converting an input string to uppercase. The developer will write this code for a manual implementation of string manipulation, and then AI could suggest this code snippet. As you can see, it's straightforward, and AI will provide to a developer a code to create a function for converting an input string to uppercase. Next example with the AI assistance in routine coding is presenting a scenario with calculating the factorial of a number. For example, the developer will write this code, and automatically the AI could suggest this code for calculate the factorial of a number. Let's continue with the quality assurance and the criticality of standards and security. Quality assurance challenge for AI-generated code could be described as verifying code quality. First of all, while I can generate functional code, ensuring it meets quality standards like maintainability, efficiency, and adherence to coding best practices remains a challenge. Traditional testing methods may need to be adapted to effectively evaluate AI-generated code. Detecting and mitigating AI bias. AI models are trained on vast datasets that may contain inherent biases. These biases can be reflected in the code they generate, potentially leading to discriminatory or unfair outcomes. Identifying and removing these biases require careful analysis of the training data and development of robust bias detection techniques. Understanding the why behind the AI-generated code. Unlike human writing code, with clear logic and reasoning, AI-generated code can be opaque in its decision-making process. This lack of transparency makes it difficult to debug errors, understand the code's functionality, and ensure it aligns with the intended purpose. New methods are needed to explain and interpret the reasoning behind AI-generated code. We need also to take into account the risk factor and potential pitfalls. AI-generated code raise concerns for safety-critical systems like embedded systems where coding standards and security guidelines are essential. There is a high probability that the code generated is not in compliance with essential industry standards such as MISRA-C, historically dedicated for automotive software, CERT C for secure coding, and Common Weakness Enumeration (CWE) common software vulnerabilities. We could have also security vulnerabilities. For example, a model trained on a VS Code base could unintentionally introduce vulnerabilities. For example, in the automotive industry, compliance with MISRA-C guidelines ensures that the software is robust against potential failures which could have dire consequences. Similarly, in cybersecurity, adhering to CERT C guidelines protects software from common vulnerabilities and exploits. Adhering to code standards and security guidelines is not merely a matter of best practice, but a crucial necessity in many domains. It's very important to understand that not compliance introduces safety and security risks. The developer's evolving role in the AI age, from writing to evaluating. In the age of AI-assisted development, the responsibility of the developers evolves. Now, developers need to evaluate AI-generated suggestions. It transcends beyond writing code to encompass the critical evaluation of AI-generated code, ensuring it meets the stringent requirements of safety, security, and compliance. Developers must be well versed in relevant standards and possess the acumen to discern when to accept AI suggestions, when to override them with manually created code. Critical focus. Ensuring AI-generated code meets rigorous safety, security, and compliance standards. Essential skills are required. Deep understanding of relevant regulation, for example, MISRA-C, CERT C, and Common Weakness Enumeration, as already mentioned previously. Discernment when to trust AI and when to code manually. While AI offers efficiency gains, ensuring compliance and security in critical domains like embedded systems requires careful strategies and focus on quality assurance. Integration and use of standards with AI tools. AI coding tools like GitHub Copilot currently don't inherently enforce specific code compliance rules like MISRA-C, CERT C, or Common Weakness Enumeration. AI tools primarily focus on functionality. AI coding tools like Copilot are primarily designed to be helpful and efficient by assisting developers with code generation and suggestions. They prioritize generating functional code that completes the desired task. Standard complexity. Enforcing strict coding standards like MISRA-C or CERT C is complex. These standards involve many nuanced rules and considerations. AI models trained on a massive dataset of code might not be able to discern all the specific contexts where these rules apply. Lack of training data. Training AI models on code that adheres to specific standards will be ideal, but such dataset might be limited. General-purpose code repositories might not have a strong focus on adherence to these standards. Proper documentation of data used for training models is a crucial consideration since these tools generate code based on the patterns they have learned from a large amount of code data, but they don't have built-in mechanisms to enforce specific coding standards or rules. The solution consists the systematic use of static analysis tools that can flag potential compliance violation. This allows developers to identify areas where their code might not be compliant. Let's delve deeper into the specific challenges and strategies for incorporating AI-powered code generation responsibly. So, let's start the next chapter, ensuring compliance and security. Boosting efficiency without omitting code quality. Automated tools offer significant benefits for ensuring code adheres to critical safety and reliability standards. Early vulnerability detection. These tools can identify potential security vulnerabilities within your code base early in the development lifecycle. This allows for prompt remediation, reducing the risk of vulnerabilities slipping into production and potentially causing security breaches. Improved code quality and consistency. Automated tools can analyze code for various compliance standards, helping developers identify and address coding practices that might violate the standards. This leads to improved overall code quality and consistency, making the code base more maintainable and less prone to errors. Streamlined compliance checks. Integrating automated tools with your development workflow streamlines compliance checks for industry standards like MISRA-C for different versions, for example, CERT C, secure coding, and common weakness enumeration. This reduces manual effort and ensures consistent application of the standard throughout your code base. By leveraging automated compliance analysis tools, you can significantly enhance the security, quality, and reliability of your code while also saving time and effort during the development process. Let's explore static analysis tools and integrate them with testing frameworks for comprehensive checks. LDRA Testbed is a comprehensive tool suite designed to empower developers with in-depth analysis and verification capabilities for their code base. CStat from IR System, it's a reliable source code analysis tool with context-sensitive online help and reporting in HTML format. LDR Testbed and CStat provide support for MISRA-C compliance and other industry standards. The latest tool is C++ Test from Parasoft. It's a comprehensive suite of static analysis tools supporting various languages, offering advanced error detection and industry standard compliance. In the next example, we will see how to use IR's CStat for MISRA-C compliance. The AI-generated code may have a MISRA-C violation here. Running this code through IR's CStat might reveal a potential violation of MISRA-C Rule 10.3, which means avoid implicit type conversions that could alter value. Now we have a revised and improved code, a code which is MISRA-C compliant, and if we run again this code through IRC stat, we will not have any more the violation of MISRA-C Rule 10.3. One step further, boosting efficiency with automated tools for continuous integration. In the context of AI-assisted code generation, ensuring compliance with industry standards is paramount. This involves an efficient approach with the use of continuous integration tools for real-time feedback and automation. Let's explore a few popular continuous integration tools. For example, we have Jenkins, an open-source continuous integration continuous development tool that supports extensive customization through plugins. It scales well for both small teams and large enterprises. Next, we have GitHub Actions, seamlessly integrated with GitHub repositories. GitHub Actions automate workflows. It's particularly suitable for individual developers and small teams. Azure DevOps, Microsoft's comprehensive suite of continuous integration, continuous development tools includes build pipelines, release management, and artifact management, ideal for Azure development. Code quality sets a baseline for target device security. Security must be a consideration throughout the development lifecycle, not just a final step, since AI-generated code could introduce vulnerabilities. Make security an integral part of the entire development process. from design to deployment. Integrate security into the development lifecycle by certified and qualified code. Secure systems are built on high-quality code. Without prioritizing code quality, achieving security is impossible, and delegating responsibility for code quality to others is risk facing security risks. Fortunately, utilizing code analysis tools offer a solution by swiftly detecting and addressing potential issues. Furthermore, development needs to perform dynamic testing and penetration testing and to uncover vulnerabilities. So, let's delve for proactive strategies. First of all, we have static code analysis, dynamic testing, and penetration testing to uncover vulnerabilities. We already saw static code analysis, but dynamic testing is to simulate real-world attacks to uncover vulnerabilities at runtime. Penetration testing mimics attackers' behavior to identify exploitable weaknesses. This goes beyond dynamic testing by simulating real-world attacker persistence and techniques. Secure coding practices to mitigate vulnerabilities, and we have also regular security audits to identify and address evolving risks. Let's go to the next chapter. The role of human oversight in AI-assisted development. While AI empowers developers to write code faster, human oversight remains crucial, especially in safety-critical domains like embedded systems. AI can generate synthetically correct code, but it may not inherently consider security best practices or adhere to strict industry standards. Human judgment is essential to ensure the code is not only functional but also secure, reliable, and compliant with relevant regulations. Human expertise complements automation. Code reviews catch issues missed by static analysis tools, logic and design flows, for example, readability and maintainability concerns. Debugging with dynamic code analysis catches issues missed by static analysis tools and code review. Why manual oversight matters. AI can generate correct code, but not guarantee compliance with strict standards, security against vulnerabilities, and then we need to allocate specific review time for scrutinizing code generated with AI tools. Human expertise in AI-assisted development. Human expertise complements the AI throughout the development process. By combining the AI's efficiency with human oversight, we can achieve enhanced trust, improved code quality, and reduced risk. Key areas from human intervention: code reviews, scrutinize for compliance, security, and design flows. Then we have data quality control for ensuring the training data accuracy. Then we have also explainability tools, interpret AI-generated code, and then security audits. Identify and address potential vulnerabilities. Benefits of manual oversight are enhanced trust, confidence in code safety, security, and quality, improved code quality, adherence to standards for reliable and maintainable code, reduced risks, minimize vulnerabilities and compliance issues. Let's delve in another example by comparing an AI-generated code versus MISRA-C compliance. First of all, we have a AI-generated code efficient but lacks MISRA-C compliance because we have here a direct hardware manipulation. But then the developer's revised code will be MISRA-C compliant after analyzing the code with static analysis tools, and we have now a controlled hardware access. Another example for exception handling in AI-generated code. This code lacks comprehensive error handling because we don't have any check for zero denominator or dividing by zero. Revised and improved code with a robust error handling. We have a defined error code for exceptional case because we check the denominator if it equals 0. So let's finish our presentation. Conclusion and call to action. Ensuring compliance and security in AI-assisted development. AI excel in efficiency. AI-powered development accelerates workflows, but vigilance is required. AI tools lack deep contextual understanding, and historical data may contain non-compliant practices. Adherence to code quality standards and best practices. AI-generated code might not align with industry standards, for example, MISRA-C, or handle error comprehensively. Ensure AI-generated code meets quality and safety requirements in embedded systems. Implement robust error handling and strategies to ensure compliance with relevant standards and best practices. Focus to security guidelines is paramount. Multifaceted approach. Static code analysis tools play a vital role in mitigating these risks. These tools can meticulously examine code, uncovering errors, security vulnerabilities, and potential violation of coding standards. By integrating static code analysis tools throughout the development lifecycle, we can ensure AI-generated code adheres to the necessary quality and safety requirements. Automated testing frameworks for compliance checks, and dedicated code reviews with a focus on standard adherence. Human expertise is important. Rigorous code reviews with static analysis tools, with contextual decision making, and with continuous learning. And then we need to understand and address challenges, understanding AI capabilities and limitation, and foster developer confidence in the quality and safety of AI-generated code. Balancing innovation with rigorous quality assurance is essential. Call to action. We will finish our today's presentation with a call to action. We need more than ever to integrate code quality and security into the development lifecycle with AI tools, but nevertheless, let's continue exploring the potential of AI-assisted development. Thank you very much for watching this presentation about code quality assurance in the age of AI assistants. Now it's time for a practical demo. Thank you again. Hi everyone. Now it's time to present you this exciting demo on code quality assurance in the age of AI assistance. As we previously seen on my presentation, ensuring code quality is crucial. And with the advancement in AI, we have powerful tools at our disposal to streamline this process. Today, we'll be using Visual Studio Code, equipped with the IR build and GitHub Copilot extensions, to demonstrate how IR CStat can assist in upholding high code quality standards when generating code with AI assistance. Before we dive into the demo, let's briefly go over the tools we'll be using. First of all, we'll use Visual Studio Code as our primary code editor. Then we will use IR build extension and integrated build chain support. Let's begin by configuring our environment. We'll start by choosing the appropriate build chain for the IR build extension. This step is essential to ensure that our project builds correctly using IR tools. In Visual Studio Code, we need to navigate to IR build extension as shown here and select the build chain that match our project requirements. This setup will provide the necessary integration between our code editor and the IR build tools. For example, we have here build tools for ARM 9.50, we have IR embedded workbench 9.40 and IR embedded workbench 9.50. Next, we will use a GitHub Copilot extension, AI-powered code completion and suggestion. We need to have an active GitHub account with a Copilot subscription. If you don't have an active subscription, you can activate it through your GitHub account settings. And lastly, we need to have IR embedded workbench for setting up CStat for compliance checks, including MISRA-C and CERT C. So for doing that, we need to go here in the properties of our project, and then in options and static analysis for the CStat static analysis, and select CStat different checks. For our demo, I will only choose MISRA-C 2004, 2012, and MISRA-C++ 2008, for example. And then we click OK. I will save my project. And now I will come back in my Visual Studio Code and I will open my demo project, which is present in IR embedded workbench. As you can see, we have almost you have the same main.c file. So let's start our demo by opening GitHub Copilot chat. I will now ask Copilot to write a code which will print a hello world string which is contained in a variable named string to print. I already created this prompt and I will just copy paste my prompt into the prompt window and ask GitHub Copilot to propose me a code. He's already generating. As you can see, it's very fast. And then what I will do is to erase everything I have here, just as an example, and I will insert a cursor, my code. I will save my code. I will then build my code, build project with IR, embedded workbench, compiler. Then I will, for example, start debugging my code with IR cspy. As you can see, my program works well. At the output console, debug console, we can see hello world. Next step, for example, is to use directly within the main.c file GitHub Copilot. I will just stop here debugging session, go here to the terminal, and then what I will do, I will just start writing creating a function, char to uppercase, and GitHub Copilot will automatically provide me a code snippet, and I just need to put tab here, and the code is already created. For the code from the function is already created. I can go here just before the printf function, and he will automatically suggest me here to uppercase to use this function with the correct variable. I can just click tab, but I can also click Ctrl and right arrow and accept the suggestion from GitHub Copilot. Then I can again run task, build my project. Then I can go start debugging. I can play and start debugging. We will see. Now I have a hello world printed in uppercase. That's it. We have a working program, but it doesn't mean that our program meets, for example, MISRA-C standards. So I will stop my program here. I will go to the terminal, and now I will run a cstat, IR cstat analysis. So we have 17 problems in our small program. We can see that the use of standard input output.h is not compliant. As you can see here, MISRA-C is not compliant. Another problem, for example, from the printf, the return value of this call, the return value of this call to printf is discarded. So we can right click here and try to fix using Copilot. He will try to fix this problem, and the Copilot will assign the return value of the printf function to a variable. So I can accept it. Then I can run again. I will again run cstat. So if I'm going back, I have now 19 problems. Why I have 19 problems? Because trying to fix the printf return value problem with Copilot, it will create yet another issue. It's important to remember that while GitHub Copilot is a powerful tool, it's not infallible. It means that the AI doesn't fully understand the context of your code the way a human would. So while trying to fix MISRA-C error with GitHub Copilot, it is possible to introduce new issues. For example, the suggested code might not take into account all possible edge cases, or it might inadvertently violate another MISRA-C rule. Therefore, it's crucial to thoroughly review and test any code suggested by GitHub Copilot. Consider the suggestion as a starting point rather than the definitive solutions. Always use your judgment and knowledge of your specific project requirements when deciding whether to accept a suggestion. That's why we need to use regularly tools like static code analysis, like IRC-stat, which can automatically check your code for MISRA-C compliance, and these tools are very, very helpful. So, before ending our demo, I will quickly show you another example. I will just create a comment with a function for divide two numbers. With this comment, GitHub Copilot will provide me a code snippet with a function which will divide two numbers. Of course, this program could be easily built without any errors, but if I run again C-stat analysis, we will maybe have another issues. Yes, we have few more issues. For example, parameter B is not checked against 0 before it's used as a divisor. What I can do now, I can run another task, and with C-stat I can generate a full HTML report, and we will see this report right here. We have in this report top 10 message by check. We can see here all the checks within this project, like here, different MISRA-C checks and so on. And on the bottom of the HTML report, we have our main C file with every tag on which its own severity and the message for every issue or which we have in our program. For example, here, parameter B is not checked against 0 before it is used as a divisor. So, as I already showed you that I can right-click here and fix using GitHub Copilot, but I can also click here where the error or issue is and go to here, Copilot, and fix this, and Copilot will provide me a solution for this issue. And I can check if this solution is convenient for me, and I can accept it. Okay, I can save my project. I can run again C-stat analysis. And then we have 26 issues. So, trying to fix an issue with MISRA-C, with GitHub Copilot, we can create another issue or another set of issues. So, we need to be very careful and to understand how we fix issues. Sometimes better to fix it manually, sometimes very good to use GitHub Copilot. But what's most important to learn from these two examples I presented to you here, that when working with GitHub Copilot, we need to be careful to understand what we are doing. It will not replace us. It will only assist us, and we need to be very, very careful what we are doing. And for conclude my demo, while GitHub Copilot can be a great aid in writing MISRA-C compliant code, it's important to use it as a tool to assist us, not as a replacement for our expertise and judgment. Thank you very much for watching this webinar and for watching this demo, and see you later on ir.com. Thank you all.